In this lecture, I'll be covering about the advanced data structure concept, that is B-trees. What is B-tree and what are the operations that can be performed on the B-tree, and that is insertion, deletion, and so on. Those concepts will be dealt within the B-tree. So B-tree, which is also called as the binary, if you consider about the binary tree, each node has the maximum of 2 children, that is a root and similarly the leaf, and the height should also be taken into the consideration. And the operations that can be performed on the binary tree, that is you can insert, you can delete, and you can search for a kind of the node, and you can perform the traversals. The applications of the binary trees, that is it is being used in the file system indexing, and it is being used in the syntax tree parsing, and as well as it can also be involved in the binary search tree. And coming to the binary search tree, it is also the same property of the binary tree, that is root node, and similarly to the maximum 2 children may be present. And within the binary search tree, the property of the binary tree remains the same, and nodes in the left subtree are less than the root node, and nodes in the right subtree are greater than the root node. And the operations that can be involved are the inserting the new node, deleting the existing node, and searching for a kind of the node, and the traversals. The applications of the binary search trees, which involves like spell check, decision trees, and as well as the data compressions, in which scenarios this kind of the binary search tree is being implemented. And similarly, coming to the AVL tree, that is AVL tree is quite similar to the BST, that is binary search tree, where it is a self-balancing tree, as we have learned about what do you mean by the self-balancing tree from the previous videos. So self-balancing tree, to give the brief overview, that is self-balancing tree is the tree where upon adding the new nodes and deleting the node, if the tree becomes unbalanced, then you have to convert this kind of the unbalanced tree to the balanced tree by performing certain kind of the rotations. And it is being used in the memory-based solution, and it can be used in compiler symbol tables, databases, and as well as the networks. The operations which involve, like you can perform the insertion, deletion, searching, and as well as the traversals operations can be performed. And coming to the binary tree, B tree. So coming to the B tree, it is also the self-balancing tree. So it is also the self-balancing tree, which allows the nodes with more than 2 children, unlike within your binary tree, binary search tree, and as well as the AVL tree. To the maximum, we can add 2 nodes for a kind of the parent node. But in the B tree, we can have more than 2 children for a node. And the operations of the B tree, which includes like inserting the node, deleting the node, searching for a particular node, and the traversals, that is in order, pre-order, and post-order traversals can be applied on the B tree. And the applications in which scenarios the B trees are being involved, that is it is used in database indexing, encryption, and natural language processing, NLP, and disk-based solutions. And coming to the introduction of the B tree. So B tree is the self-balancing tree data structure that maintains sorted data and allows searches, sequential access, insertions, and deletions in the logarithmic time. And B tree is well suited for the storage systems that read and write relatively large blocks of data, such as the databases and the file systems, indicates at which scenarios this kind of the B tree is being implemented. So what is actually the B tree? So B tree is a special type of the self-balancing search tree in which the node can contain more than one key. A node can contain more than one key and can have more than 2 children. Also, it is also known as height balanced M-way tree. The height of the B tree is kept low by putting the maximum possible keys in the B tree node. And the B trees are balanced search trees designed to work well on disks or other direct access storage devices. So I'll explain in detail about the B tree with the suitable inserting the nodes, deleting the nodes, and so on. This is a theoretical part of how we can explain about the B tree. So a B tree of order M is defined to have the following shape properties. The properties are, that is, root is either leaf or has at least two children. And each internal node, except for the root, has between m by 2 and m children. And all the leaves are at the same level in the tree, so that the tree is always height balanced. And there are also certain other properties which are being given in the B tree, the theoretical explanation. That is, a B tree of minimum degree t greater than or equal to 2 has the following properties. The properties are, that is, every node X has the following attributes. Those attributes, that is x dot n equal to, which indicates the number of the keys that are currently stored in the node X, and keys are stored in the increasing order, that is x dot key 1 is less than or equal to x dot key 2 less than or equal to x dot key 3, and so on. And x dot leaf, basically it is a boolean value which denotes the true or false. So true if x is the leaf node, and false if the x is an internal node. And all leaves have the same depth, which is the tree's height h. And nodes have the upper and the lower bounds on the number of the keys. That is, every node other than the root has x dot n greater than or equal to t minus 1 keys, and where every internal node other than the root has greater than or equal to t children. And every node may contain x dot n less than or equal to 2t minus 1 keys, and an internal node may have less than or equal to 2t children, that is m equal to 2t. And a node is full if it has x dot n equal to 2t minus 1 keys, and the root has at least 2 children if it is not the leaf node. So consider about the operations, that is how we can insert, how we can delete, and the various operations that can be performed on the B tree, considering the insertion. That is, if the node contains less than mxk, that is maximum allowable keys, then insert the new key in the node ordered. Otherwise, the node is full. Then in such cases, evenly split into the two nodes. I'll explain in detail with the suitable diagrams of the B tree of how this kind of the insertion is being performed. A single median is chosen from among the leaves element and the new element that is being inserted. And values which are less than the median are put in the new left node, and the values which are greater than this kind of the median value that you have calculated are put in the new right node, with the median acting as the separating value. The separation value is inserted in the node's parent, which may cause it to be split, and so on. If the node has no parent, that is the node previously it was the root, create the new root above this node, and thus increasing the height of the tree. Now the actual part of the demonstration of the B tree inserting will be provided. So consider here construct the B tree of order 3 by inserting the following keys. So within the B tree, the order is also been given. The order which like 3 is been given, that is maximum 3 keys can be present. So here, according to this kind of this scenario, you need to insert the nodes which contains the values to be equal to, that is 1, 2, 3, 4, 5, 6, 7, 8. So the solution is here given what is the order, that is m equal to 3. And for the instance, just have the glance about what is the minimum keys per node. That is, unlike in the case of the B tree, as we have studied within your binary tree, a binary search tree, and similarly the AVL trees, when I say the node, it contains only one key. But unlike in the case of the B tree, when I say the node, it may contain more than one key, and the node can contain more than 2 children. That is what the property of the B tree has been explained. So have the glance about what are the minimum keys per node should be present. That is based upon the formula, that is m by 2 minus 1, that is that will be equal to, that is 1. Ceiling function is being implemented. And minimum number of the children per node. What should be the minimum number of children that has to be present for each node? That is being given by m by 2 that is equal to 2, where m indicates what is the order that is provided in your input itself, and you have to apply the ceil function. And maximum keys per node, that is which is being denoted by mxk, and that is equal to given by the formula m minus 1. So m is equal to 3, so 3 minus 1, that will be equal to 2. So the maximum keys that can be allowed per node is equal to 2. And so maximum number of children per node, how many number of children that can be present for the node is given by, that is m equal to 3. That indicates how many number of what is the order that is being provided, that is the maximum number of children that can be present for the node. So if you need to construct the B tree of order 3 with the following keys, that is 1 2 3 4 5 6 7 8, then in such cases, as I mentioned about what is the maximum minimum number of keys, minimum number of children, maximum number of keys, maximum number of the children, based upon the previous formulas that we have computed. So here when you need to insert node 1, so node 1 can be inserted, this becomes your leaf node or the root node, because there is only one node that is present. And whenever you are inserting the node 2, so consider the node 2 has to be inserted, and check what is the maximum allowable keys per node, that is 2. So here there are 2 keys, that is key 1 and similarly key 2. So this can be included within the single node. That is, key 1 and key 2 can be present as the single node. If it exceeds, then you have to split, and how the split is being involved, that will be discussed. Now consider the next node, next key that has to be inserted is equal to 3. So when you need to insert the key 3, then where is this key? As I mentioned, it should be in the sorted fashion. That is, if you are inserting at the first scenario, like take for example, you need to insert the node, you need to insert the node 10 in the first scenario, and something like your node 11 in the next node 12 in the next scenario, and node 11 in the next scenario. So assume the given input is, that is node key 10 comma 12 comma 11. Assume these are the keys which are to be inserted. Then in such cases, upon inserting the node 10, directly you can insert node 10, and the next scenario, if you need to insert, that is node key 12. So key 12 has to be placed towards to the right of node 10, because it should be kept in the ascending order. And when considered about to insert the key 11, so when you need to insert node 11, already we have the contents like your 10 and 12. Assume the order is equal to 4 or higher degree. Then in such cases, node 10 is already been present, and 11 should be placed towards to the right of the key 10 and then 12. This is what you need to observe, how the nodes are, the keys can be inserted within the B tree. It is in the sorted fashion. And according to our example, so according to our example, you need to insert, that is 1, 2, 3, 4 and so on. So when you are inserting the key 3, so key 3, and check what is the maximum keys that is being allowed. So what is the maximum keys that is being allowed? That is 2. That indicates a node can contain to the maximum of 2 keys. And here, according to this case, that is here there are 3 keys which are being present, which is not allowed. In such cases, it has to be split. How to split? That is, consider this is your numbering value, that is 1, 2, 3, not the keys, in the numbering order 1, 2, 3. And similarly, identify the split which is being given by ceil of m by 2, that will be equal to 2. That indicates, what does this split value indicates? You have to split at 2. That is, at this we have to split. That is, make 2 as the root node, and the left child will be equal to 1 and the right child will be equal to 3. This is how the split has to be involved in the binary tree insertion when the maximum allowable keys are being exceeded. What is the maximum allowable keys? That is 2 keys, because we have computed mxk is equal to 2, which denotes at each node to the maximum we can allow 2 keys to be stored. What happens if more than 1 key is to be involved in the node? Then in such cases, split. And how to find the split? Which has been given by the formula, that is m by 2. That is CL of m by 2, where m indicates the order, and CL of m by 2, that is 3 by 2, that will be equal to 1.5, and to the next highest integer, that is equal to 2. So that is what you got the value to be equal to 2. And what is this split value 2 indicates? At your second position, you have to split. How to split? Make that kind of the value which has been stored on your 2, bring it up, that is it becomes the root node, and place the left child as 1 and similarly the right child as equal to 3. That is what the split factor has been involved in the binary tree. And coming to the next key that has to be inserted. So the next key that has to be inserted is, that is node 4. And when you need to insert the node 4, where actually the node 4 has to be placed, it starts searching from the root node. It is the greater value, that is node 4, key 4 is greater, and that is how it traverses towards to the right. And node 4 is being placed to the right of the node 3. So node 4 is being placed to the right of the node 3. And then find whether it is the maximum allowable keys are being involved. So here, because at this node, there are 2 keys. At this node, there are 2 keys which are present. So it is allowed. Beyond 2 keys, it is not allowed. So far, there are 2 keys, and that is how this is the valid B tree. And take the next kind of the tree, that is equal to, next kind of the key, that is equal to 5. So where is actually the 5 has to be inserted? 5 has to be inserted supposedly on to the right of the node key 4. So to the right of the key 4. And check whether what is the maximum allowable keys per node. The maximum allowable keys per node is equal to 2 only. But here there are 3 keys, and that is how you have to find the split. So how to find the split? Position like 1, 2, 3, and similarly find the split which has been given by m by 2, that you can identify at the second position. You have to split. What has to be done? Make split this kind of the node 2's content and bring it up. So 2 and 4 becomes the keys which are present at your root node. 1 as the left child, and 3 is been connected to the right of the node, key 2, and similarly 5 is been connected to the right of the key 4. And that is how, and upon inserting the new node, like take for example, if you want to insert something like your, assume if you want to insert the node at this location. Further, once again, this is being split, and this is being made as the root node 4, and similarly 2, and the next value, and so on. This is how the B tree is being inserted. The keys are being inserted. So depending upon the order, find what is the maximum allowable keys. If it is within the maximum allowable keys or equal to the maximum allowable keys, then it is okay. If it is not, that is if it exceeds, that is here you can observe there are 3 keys supposedly to be present. But since the maximum allowable keys are equal to 2, and that is how you have to identify the split, which is being given by the formula, that is m by 2. And after splitting, there is the location, like here in this case, the split value is equal to 2. You are moving this kind of the second position key to the you are bringing up, and by bringing up, check whether this node is been affected. What does it mean? That is when you bring the node key 4 to the root level, that is 2 and 4 are been present, and assume already there are 2 keys which are present at the root node. By adding this one, it becomes the 3 keys are being present, so it is not allowed. And that is the purpose where find the split and bring the split value out of the root node. That is what this procedure is been involved. Similarly, if you consider the inserting the node, the key 6. So key 6 can be inserted to the right of the node 5, key 5. So here, how many number of keys are present at this node? There are 2 keys, that is 5 and 6. It is allowed. So you can directly insert the key 6. And when you need to insert the key 7, where actually the key 7 has to be placed to the right of the node 6, the key 6. So when you are inserting to the right of the key 6, what is the maximum allowable keys? That is 2 keys. So here there are 3 keys which are being present. So find the split. Split will be equal to 2 depending upon the order. So split equal to 2. What does this interprets? That is 6 that is a key with the 6 has to be pushed up. When you are pushing up, then this node is also been affected. The root node is also been affected. What does it mean? Because the maximum allowable keys are only 2. But by pushing this key 6 to the up, then there are 3 keys which are present at the root node. That is 2, 4, 6. Find the split. That is split equal to m by 2. That will be equal to 2. And push this kind of the split value to the up. That is node 4 becomes the root node. Node 2 becomes the left child. Key 2 becomes the left child. And similarly key 6 becomes the right child. And to the left of the key 2, that is you have the 1. And to the right of the key 2, you have the key that is 3. And similarly 5 is been attached to key 6 and 7 is been attached to, that is key 7. This is how we can implement this kind of the B tree. And so far, that is we have constructed the B tree with the following keys, that is 1, 2, 3, 4, 5, 6, 7, and key 8 has to be inserted. Of course, you can directly insert key 8 to the right of this key 7. So key 8 can be inserted because by inserting this kind of the key, it does not exceeds the maximum allowable keys. So key 8 can be inserted to the right of the key 7. And take another example, like if you need to construct the keys from 1 to 11 with the order to be equal to 3. So, so far we have learned like how to insert the keys provided with 1, 2, 3, 4, 5, 6, 7, 8. And this is how the scenario looks like whenever you are inserting the nodes from 1 to 10. So, and what is the next key that has to be inserted? The next key that has to be inserted is, that is 11. So when you are inserting the 11, then it becomes 3 nodes will be present. That is, here you can observe upon inserting the node 11, upon inserting the node at this level, this there are 3 keys which are being present, which is not being allowed because the order is being given as 3. So that is how you are pushing up 10 over to the up. So 10 has to be placed here in this right to the right of the key 8. And by pushing up, this node is being affected. And when this node is being affected, find the split and push the split value to the up. So 4 and 8 becomes the root node. The keys 4 and 8 becomes the root node. Left child will be equal to 2 and the right of the node 4 will be key 4 will be equal to 6. The right of the key 8 will be equal to 10. And similarly 1, 3 is being placed to the as the children of the key 2. And similarly 6, 5, 7 are being placed as the children of the key 6. And similarly 9, 11 are being placed to the children of the key 10. This is how we can insert the nodes provided with the respective keys and as well as the order. Now take for example, if you need to construct, so far we took the order to be equal to 3. Now consider you need to construct the B tree of order 4 by inserting the following keys, that is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 and so on. So the solution is find what is the maximum allowable keys. The maximum allowable keys is m minus 1, that will be equal to 3. That is, at any stage you cannot include more than 3 keys in a node. So here provided with the keys and provided with the maximum allowable keys, that is equal to 3, you can insert the first key, that is insert 10. 10 can be inserted, and similarly 9 is been inserted towards to the left of the key 10. That is what I've said. When you are inserting the new key, make sure that it is in the ascending order. That is, 9 should be placed towards to the left of the key 10. So 9, 10, and similarly in inserting the node 8, that is node 8 has to be placed towards to the left of the node 9, key 9. So here what is the order? Order is equal to 4. And what is the maximum allowable keys? The maximum allowable keys is equal to, that is 3. And hence this property has been satisfied. That is 3 keys can be present in a node. But when you are inserting the 7, that is key 7, when you are inserting the key 7, where should the 7 has to be placed? 7 has to be placed towards to the left of the key 8. And by inserting the key 7, what is the key? How many number of keys are being present at this node? That is 4 keys are being present. And what is the maximum allowable keys? That is equal to 3. And hence find the split. and split is been given by m by 2. So number accordingly, that is 1, 2, 3, 4, and find the split, that is m by 2, that will be equal to 2. And what does this 2 indicates? The second position key has to be moved up, that is 8 becomes the root node and 7 becomes the left child, and similarly 9, 10 becomes the right child of the key, that is 8. Similarly, go for inserting the next node. So the next node that has to be inserted is 6. So when you are inserting 6, where the 6 has to be placed? 6 has to be placed to the left of the key 7, because it should be kept in the ascending order. So here 6, 7 is been included. It does not violate the maximum allowable keys. So 6 can be placed, and insert 5. So where 5 has to be inserted, the 5 has to be inserted to the left of the key 6. So check whether it violates the maximum allowable keys. It does not exceed, because 3 keys can be stored in the node. So node 5 is being stored within the left of the key 6. And when inserting the next node, that is node key 4. So key 4 you are inserting, and that is how you can check in this kind of this scenario. There are 4 keys which are present in the node. And what is the maximum allowable keys? The maximum allowable keys are equal to, that is 3. So here there are 4 keys which are present, number accordingly, that is 1, 2, 3, 4. Find the split equal to m by 2, that is at the second position. And what is the key that is present? That is 5. Push this kind of here the 5 to up, that is 5 and 8 will be the contents of your the root node, and similarly 4 that is left, and similarly 4 and 6 are the children of your the key 5, and 6, 7 to the right of the key 5, and to the key 8 the right, or that is 9, 10 respectively. And when you need to insert, that is node key 3. When you are inserting the key 3 can be directly placed to the left of the key 4, because it does not violate the property of your the maximum allowable keys. And take the next key, that is 2. So 2 can be inserted. So there is actually the 2 has to be inserted. 2 has to be inserted towards to the left of the key 3, and check whether it is the maximum allowable keys or not. So maximum allowable keys are equal to, that is 3. So 3 keys are being stored, and hence it is the valid B tree. And take the next key, that is you need to insert the key 1. So when you are inserting, where actually the key 1 has to be placed, key 1 has to be placed to the left of the key 2. And when you are inserting 1 at this position, you can observe there are 4 keys which are being present. So when there are 4 keys in the node, you have to find the split and split accordingly. So number 1, 2, 3, 4, find the split m by 2, that will be equal to, that is at the second position. You are moving the node, the key 2 to up. So 2, 5, 8 will be the contents of your the root node, and it is allowed because the maximum allowable keys are equal to 3. And 1, 3, 4 will be the children, and similarly 6, 7 will be the right of your the key 5, and 9, 10 will be the right of your the key 8. This is how we can insert the values. We can construct the B tree with the order 4 for the following kind of your the case, ranging from 10 to 1. And for the simplicity, like take another example, like construct the B tree of order 3, and you need to insert the keys with the keys to be equal to 5, 3, 2, 9, 8, 6, 10, 12, 1, and so on. So what is the first thing that you have to do? Find what is the maximum allowable case, because it depends upon the order. So here the order is equal to 3, and the maximum allowable keys per node is equal to 2, and that is m minus 1. So here insert the first key, that is 5 can be inserted directly, and the next one insert 3, where the 3 has to be placed. 3 has to be placed towards to the left of the key 5. So key 3 is being inserted to the left of the key 5, and the next one, that is insert 2, that is upon where the 2 has to be inserted to actually to be inserted to the left of the key 3. But what is the maximum allowable keys? Maximum allowable keys is equal to 2. So find the split equal to m by 2, that will be equal to 2, and similarly push up this kind of your the split value to the upper, that is key 3 becomes the root node, and to the left, that is 2, that is key 2, and to the right, that is key 5 will be stored, and take the next key that has to be inserted, that is 9. So when I take the key to be equal to 9, that is where actually the 9 has to be stored. 9 has to be stored within your right of the key 5, and check whether it allows the maximum allowable keys. What is the maximum allowable keys? That is equal to 2, and hence that is 9 is being stored to the right of the node 5. And coming to the next one, that is insert the next key, that is 7. So when you are inserting the 7, then where actually the 7 has to be placed in between 5 and 9. So 7 is being placed in between 5 and 9, and check what is the maximum allowable keys. The maximum allowable keys is equal to 2, and hence here there are 3 keys, and that is the purpose where push this can afford the split value to the up. So now the root contains 3, 7. So the root contains 3, 7. The left will be 2, and to the right of your the 3, it is equal to 5, and to the right of your the key 7, that will be equal to 9. This is how we have inserted these kinds of your the values. And in your next video, I'll be covering some more examples related to the B tree.